So we're going to take a small detour on this topic of conic sections, or um, simply put as conics. It's very interesting. We'll just look at a general kind of a fly through this topic, and hopefully somebody who wants just a quick dive through this topic in one sitting, this is what we're going to try and do. Um, so let's jump in and see what this topic is all about. So as we all know, this topic is all about a cone. And so if you have two cones and their tips touching one another, and you have a knife going horizontally at any point on those cones, you definitely are going to have two circles as the cross section of those cones. And then if you slant your knife so that it cuts at an angle that doesn't touch the base, but it's slanting, then those two cross sections will be an ellipse. And then if the angle is increased so that it cuts through the base, then you're able to extract a parabola as a cross section of that cut. Then if you take your knife until it's more vertical, you have a hyperbola set that is depicting the cross section of the cut. So that's all about conic section. We're going to look at one circle, two ellipse, three parabola, and then four hyperbola. So looking at this circle as you see here, the cross section obviously is a set of points that are equidistant from a specific point. And as we see, we have two cones here, and I chose two cones instead of one for a reason that will become apparent shortly. But if you cut it at two at any level, you at any point can get either a circle at that point on the top cone, or you could still get another circle from the bottom cone. So one of those would suffice. And obviously, as you move up and down at different levels, the radius of the circle changes. Now, as we said, a circle is a set of points x, y that are equidistant from a given point or the center of that circle. So if we take AB to be the center of that circle, the distance, that constant distance radius r, will hold for any point on that circle. So and the equation for this is very simple. So r squared is going to be equal to x minus a squared plus y minus b squared. And that is a general equation of a circle. Nothing complicated, easy as it is. Then, as we saw, the ellipse is the cross-section that is obtained when the knife is slanted such that it's not touching the base but also not horizontal. So any cross-section that is in between those two limits is an ellipse. And so that would be your cross-section, or from the bottom cut, you would get a cross-section if the level are the same. Now, for an ellipse, what happens is that it's a set of points x, y, such that if you have two foci or foci, the distance d1 plus d2 is constant. Those are the governing principles for an ellipse. So the xy set of points such that if you have two set of foci that are given, the distance d1 plus d2 is constant. And this you could do this very simply if you have a two pins, and you put them at 2 points on a straight line, and then you tie a string that is longer than the distance between those 2 pins, and you tie them on those pins, and you place a pencil such that the thread or that string is taut. If you run that spring all around, it's going to trace an ellipse. So that's what it's telling you, that string length is going to remain constant, but as you move around those pins, it's going to give you a locus or a set of points x, y that is an ellipse. So let's use those 2 parameters to derive a general equation for a simple ellipse. So we have an ellipse that, let's assume we have the d1 and d2 as the distance from foci 1 and foci 2 respectively, and we say that sum is constant, and so x minus x1 squared plus y minus y squared square root is d1, and then x minus x2 squared plus y minus y2 squared square root is d2. That is equal to the constant, the distance or the length d. So if we assume that this is an ellipse that's centered at the origin, and the foci, one focus is negative c, 0, and the next focus is positive c, 0, and then the point for which that ellipse touches the x-axis on the negative side is negative a0, and on the positive axis, on the positive side of x is a0. So what happens is then we have x plus c, so x minus minus c is x plus c squared plus y minus 0 squared square root plus y minus x minus c squared plus y minus 0 squared square root is equals to d. So then this is just x plus c squared plus y squared square root plus x minus c squared plus y squared square root, which is still equals to d. Now we want to find d because this is obvious. When xy is at a0, then what that means is that the length d1 is going to be equal to, so d1 is going to be this length, which is obviously 2c, because from here this is c, and this is another c, c, and then there is obviously this distance here from c to a, so this is a minus c, so 2c plus so d1 is 2c plus a minus c, which is equals to a plus c. Then d2 is just going to be equal to a minus c, because it's again this distance here, which is a minus c. So in other words, the constant distance is equals to a plus c plus a minus c, which is 2a. So d is 2a, and therefore x plus c squared plus y squared plus square root of x minus c squared plus y squared square root is equals to 2a. So we've found that our d is now 2a. And so you can now take this onto the right hand side. So we have things shuffle around, and so if we square both sides, the square root sign drops off, and then we have 4a squared plus 4a. This is actually a minus, we apologize, and as we go on we see that this is still minus, we see that this x and this x cancel, this c and this c cancels, y and y cancels, and so eventually we get this negative going onto the left hand side, and so we still have minus here, sorry. So we have 4cx equals to 4a squared. 4a squared minus 4a square root of x minus c squared plus y squared. Then you take 4a this side, we have negative 4a square root of x minus c squared plus y squared square root on the right hand side. So we can divide both sides by 4, and on the right hand side we have negative a square root x minus c squared plus y squared, and on the left hand side we have cx minus a squared. Then if you now square both sides, the negative disappears, so we're okay from here forward. And so we have cx minus a squared is equals to open bracket a times square root of x minus c squared plus y squared. And so this is cx squared minus c squared x squared minus 2c squared x plus a squared is equals to a squared times open bracket x minus c close bracket squared plus y squared. And you can go on and simplify it further until we come to a point where you realize this and this cancel out, and so we have a to the power 4 minus we've pulled this, and so we have it on the left hand side, and we've taken this to the right hand side, and that's what constitutes this minus c a squared minus c squared all in bracket times x squared, and then we have a squared times y squared, we have a squared y squared. We can pull a squared out on the left hand side, so we have a squared times a squared minus c squared, which is equals to a squared minus c squared x plus a squared times y squared. You can divide across by a squared times open bracket a squared minus c squared, and so on the left hand side we have 1, and then here we have this part, and that part cancels, and then we have a squared over a squared minus a squared minus c, a squared times minus a squared c squared, and so we have the a squared cancelling, and so we have 1 equals to x squared over a squared plus y squared over a squared minus c squared. Now if we let a squared minus b to be equal to b squared, then we get a more general formula for a simple ellipse that is that the major and the minor axes are coincident to the major x and y axis. So that this is just a simple general formula for an ellipse, and if a squared is longer or is bigger, then that means that the major axis lies on the x-axis, and if b squared is greater than a squared, then we see the major axis, that's the longer axis, coincident on the y-axis. So that's just a quick representation of an ellipse. Now for the case of the parabola, where we said if you cut so that the knife edge goes through the base but not quite vertical, then you have a shape like that representing the cross section. Or if the knife was going downwards, you'd have a something like that. So one of those represents a parabola. Now what does a parabola mean? A parabola is just a set of points or a locus for which the distance from any point on the parabola xy to a point to a line called the directrix equals to the same the distance from that same point to a focus of that parabola. Now the directrix here, we're giving a more general representation, a very simple representation of an ellipse whose major axis or whose axis is coincident on the y-axis, and so the focus is taken to be 0, A, and the directrix is a point that is reflected, that is of equal distance from the apex of that parabola to the focus on the opposite side. So let's look at just how we could derive the formula for this parabola. So we say that the distance from that point to the directrix, that means y plus a, because the directrix is at negative a, y plus a squared equals to x squared plus y minus a squared. So this here is the d1 representing this length, and this is the d1 representing this length to the directrix, actually d1 squared. And so when we expand it, we have y squared plus 2ay plus a squared equals to x squared plus y squared minus 2ay plus a squared. And as we can see, the y squared cancels, the a squared cancels, and so this can be taken to the left hand side, and we have 4ay equals to x squared. So this is a general formula for an ellipse that is whose apex is at the origin, but also the axis, its axis constant on the y-axis. And then if the axis is constant on the x-axis, you just flip the x and y so that the general equation is 4ax equals to y squared, right? So as simple as that. We'll as we go on, we'll dive into the more general and more detailed derivation of these formulas. But this is just a simple introduction. If you have any questions, please feel free to leave a comment on the comment section, or email us if you can. Then the parabola, as you can see, the knife edge is vertical going through the two cones, as you can see. Now we are saying and not just or. So you have the knife creating those two shapes as it goes through the cones, and this is a hyperbola for us. And the general concept around a hyperbola is that if you have two foci on the two shapes, the difference between d1 and d2 is constant. For the ellipse, we had the sum was constant. For the hyperbola, the difference is constant. And so let's go ahead and show how we can get a more general formula for hyperbola that have the axis constant on one of the major axes, x or y. So this is just what we had previously, and we're saying d1 minus d2 is equals to d, which is a constant. And so d1, let's first of all find what d is. When x, y is at a0, that means that d1 is equals to a plus c. So as you can see, if we are at this point, that means that the distance d1 is all the way here. So we have from here to here is c, from here to here is a. So d1 is a plus c. And then d2 is just going to be equal to c minus a, such that the difference d1 minus d2 is a plus c minus, c minus a, and this is equals to 2a, right? So therefore now d1, which is x minus c plus y minus c squared plus y minus 0 squared, minus d2, which is x minus c plus y squared, is equals to 2a. Now we can take this onto the right hand side, and so the plus there is correct. So, and then when you square both the left and the right hand side, we have x plus c squared plus y squared is equals to 4a squared plus 4a square root x minus c squared plus y squared plus x minus c squared plus y squared. We expand everything as shown here. We see that sometimes they're going to cancel one another, like this and that will cancel, this and that will cancel, and then let's see, this c squared will cancel. Then we can take this onto the left hand side by adding both sides, and so we have 4cx is equals to 4a squared plus 4a times the square root of x minus c squared plus y squared. And so cx minus a squared is equals to, after dividing by 4, is equals to a times square root of x minus c squared plus y squared. Going forward, as we can see, if we square both the left and right hand side again, we have cx minus a squared all squared is equals to a squared times open bracket cx minus c squared plus y squared. So we expand whatever is on the left hand side and what's on the right hand side. You can see that we can also take this a onto the left hand side, and since a is less than c, from the diagram we have c squared minus a squared times x squared plus a to the power 4 is equals to a squared, and as you can see these two terms would also cancel one another since we have an a squared out here. So we have a squared times c squared plus a squared times y squared on the right hand side. Keeping this term as it is, we can also bring a squared y squared onto the left hand side by subtracting both sides, and so taking a to the power 4 to the right hand side, we have a squared minus c squared minus a to the power 4. On the left hand side, if we bring out the a squared, as you can see we have something similar to what we saw with the ellipse, but we have a minus sign here. Divide both sides with a squared times c squared minus a squared. We get c squared minus a squared over a squared times c squared minus a squared. This would cancel. This times x squared minus a squared over a squared times c squared minus a squared, and the a squareds cancel. And so we have now here x squared over a squared minus y squared over c squared minus a squared is equals to 1. And if we set c squared minus a squared to be b squared, then we have a general formula for a hyperbola whose axis is coincident with one of the major axes, but specifically here we're looking at the x-axis shown here. And again, depending on which one is greater, the major axis changes. So ladies and gentlemen, that is quickly a run through the conic sections. We'll keep building on this topic. We're going to have more interesting and detailed look at it and come up with some interesting formulas. But this is just a basic introduction to this topic. I hope you have an interesting time running through it. If you have any questions, feel free to reach out to us. Till next time, bye-bye.